uh, thank you for the reminder. I keep forgetting that. All right. And now let's take a look at the next number, 5.5. We want to round it up to one sig fig. One sig fig is that first number. So we have to look at the neighbor to determine whether that 5 stays 5 or goes up. Now remember, when you round the number doesn't go down. That number that you're going around either stays at that number or goes up one integer. Okay. Look at the neighbor. 5 is greater or equal to 5. Therefore, the 5 at the one sig fig position becomes 6. Okay. Becomes 6. So it's a simple thing. Look at the neighbor. If the neighbor is less than 5, then that number stays the same. If that number is greater or equal to 5, then the number you're going to round goes up. Okay. Now, but don't change the magnitude of the number. Okay. What does that mean by changing the magnitude of the number? Okay. Take a look at the number down at the bottom. It says round to one sig fig. So you're given the number 5,400. Okay. The magnitude what was that? Hold on, I got a question here. The chapter 2 activity, it seems like chapter 3.
So chapter 2 is most likely talking about the math skills.
Yes.
And chapter 2, yeah, the quizzer basically talking about the units and conversions. So yes. Is this the wrong or am I just tripping?
Now, chapter 3, we're going to actually start doing some conversions. Is that the question you asked?
Yeah, but I try to do the activity 2 right now.
Uh-huh.
However, the question's asking like I need to make like conversion problem. For example, like Emily drinks 0.745 liters of cranberry juice. How many cups is this kind of thing? Yeah. Which is we're gonna talk about in chapter 3.
Yeah. So okay. So I need to check that. Dr. Kim created that activity. So what you're saying is the activity for chapter 2 really should pertain to chapter 3.
Yes. Okay. And then on chapter 3 there was no activity, so I was like, maybe. You know.
Okay.
So can I just exit?
Yeah, you can exit. Yeah, exit that, and I can go in there and give you another attempt at it. Not a problem. That's a good point.
Oh, okay, thank you so much.
No problem. No problem. Okay, where are we at? All right, so taking that number down at the bottom, 5,400. The magnitude, you're in the 5,000 range, okay? 5,000 range. So when you round your number, you don't want to drop everything before the decimal point. What do I mean by before the decimal point? If this 5,400 had a decimal point, it will go right there. Everybody agree on that, right? And so any numbers before the decimal point get converted to 0. Okay, any numbers before the decimal point get converted to 0. Any numbers after the decimal point, you drop them off. You just get rid of them because you don't need them. But the numbers before 0, before the decimal point, tell you the magnitude. So if we were to round this number to one sig fig, so we go starting from left, 5,400, one sig fig, that's the very first number. So now we got to determine whether that 5 goes to 6 or stays at 5. And we look at the neighbor's 4, it's less than 5. Then based on our rounding rules, that 5 remains 5. We replace that 4 with 0, and now we have the number 5,000. Okay, because you're still in the 5,000 mark. That's your magnitude. Don't drop it off and end up with just 5. because you have totally changed the magnitude if you don't put those zeros back. Ask yourself, do I want $5,000 or I want $5? Okay, there's a big difference in magnitude. Okay, so that's what we're talking about when we talk about change in magnitude. And what generally is the error is when we start getting rid of numbers before the decimal point, students tend to drop those zeros and we end up with 5. Don't do that, okay? So recognize what your magnitude of the number is, and you want to stay in the same magnitude when you round your number to whatever number of sig figs you need to be. Yeah. I would check that activity, Alexis. I would check it again. And if you guys started it, no problem. I can go in there and give another attempt. That activity was created by another instructor on the fly. So we're still learning. So no problem. I will give everyone another attempt at it. For those of you not following, the activity 2 asks you to convert numbers, which is really related to chapter 3, which is the next one. Okay. All right, so that's rounding numbers. So here we have this scenario where they're asking you to round these numbers off to 3 significant figures. Okay, so we got to find the position where it's 3 sig figs. So starting from left to right, we recognize that the 3 is the 3 sig fig position right there, okay? That means that everything to the right of the 3 is going to be dropped. Why? Because we're behind, we're on the right of the decimal point. If we were in front of the decimal point, anything to the right of the 3 would be changed to a 0. Because here, we want to put zeros in here because that changes things. Okay, and I'll explain that in a second. So first identify the sig fig position, which is a 3. Look at the neighbor, which is a 7. Use the rounding rules. Is it greater than 5? Yes, it is. 7, so therefore that 3 becomes 4. And so our answer becomes 1.84. Now you may ask the question, well, wait a minute. What if I added, let me do this here. What if I added zeros to replace the 7.4 and they end up at 1.8400? Okay. What if I did that? What would be wrong with that? Who would like to speak up? Since
it creates the more sig figs.
Exactly. You have created more sig figs because now those zeros count. Okay, ask the question. Is there a decimal point? Yes. Is there an integer? Yes. So now you created 1, 2, 3, 4, 5 sig figs. The question said you want 3 sig figs. Okay. All right. So that's good. Good point there. All right. So this next one, again, same question. Round it off to the 3 sig fig position. Okay. And so we got to find the 3 sig fig positions starting from left to right. That would be the 6. Okay. Now look at the 2 right afterwards. It is before the decimal point. So you got to remember, I got to put a 0 in there. Why? Because if I don't, I change the magnitude. I am in the 7,000 range magnitude, 7,000. Okay. Anything after the decimal point, I can get rid of. It doesn't change the magnitude. Okay. So keep that in mind when you start doing that. Is that number following the sig fig position? Is it before or after the decimal point? So now the 6 remains a 6 because the neighbor 2 is less than 5. So 6 remains 6. The 2, we replace it with a 0. We drop everything after the decimal point and we end up with 7,160, not 716. Again, that changed the magnitude by not remembering to do that. Here, 3 sig fig positions. Keep in mind that these are leading zeros, so they are not significant. So starting for the first integer and moving from left to right, that means that this one, the first one, the third one, excuse me, the one right after the 3 is a 3 sig fig position. We are after the decimal point, so therefore any numbers to the right can be dropped, no problem, because we're not changing the magnitude. We look at the neighbor to that 1 that I underlined is less than 5, so 1 remains 1. So that number becomes 0.00135, okay? And finally, not finally, I think, yeah, maybe 24,925. The 9 is in the 3 sig fig position. Look at the neighbor, which is the 2. That tells you that it's less than 5. Therefore, the 9 remains 9. We're in front of the decimal point, so the 2 and the 5 get replaced with zeros. Okay, and we don't drop them off, because you're going to end up, remember the magnitude here, you're in the 24,000 range. Dropping those zeros will give you down in the 200 range. Okay. When it comes to, okay, we're learning sig fig, so what we're going to do with this. All right. Now, let me hide this thing so I can see where I'm at. All right. When we multiply and divide, we first identify how many sig figs we have. Okay, and that's that whole exercise we just did. And then we write all the numbers out. Once we identify how many sig figs we have, your answer cannot have more sig figs than the number that had the least number of sig figs, okay? And that's where you're going to truncate it by rounding up or rounding or leaving the number the same, okay? Now, when we add and subtract, sig figs do not play a factor. Decimal places, okay? Don't confuse the two. Multiply, divide, significant figures. Add, subtract, decimal places, okay? So your answer should have no more decimal places than that number that has the fewest decimal places, okay? For example, 13.5478 feet, we're going to subtract 11.20 feet, okay? Obviously, the 11.20 has 2 decimal places, and the 13.5478 has 4 decimal places. So you do the math completely, that's your full answer. But realizing that the 0.22 has only 2 decimal places, your answer should have no more than 2 decimal places. And so you would need 2 decimal places. So that means I'm going to have to truncate everything to the right of the 4. And this is where you bring in the rounding rules. Look at the neighbor. The neighbor is greater than 5, therefore that 4 becomes 5. And so our answer is 2.35. And you think about it, you know, it makes sense here because you're measuring, you know, here the top number is extremely accurate. You probably had a very accurate measurement tool. But the second one, you only went to 2 hundredths place, 2 decimal places. So your answer cannot be more accurate than the least accurate measurement, which is the 11.20. Okay. All right. Now, so round the numbers off. Now, don't round anything off until you do the math. So if you're given 13.5478, keep it at that, and then whatever numbers you're given, use those numbers, complete numbers, you know, as far as your answer, and then round it off after you do the addition or subtraction. So don't round them off beforehand. You propagate the error, okay? So key thing to remember, adding, subtracting, focus on decimal places. This is a reminder here with respect to decimal places and where they at magnitude-wise, okay? You're welcome to read it. Now, multiplying and dividing, final answer should have no more sig figs than the least sig fig. So here we have 3.546 times 1.4. Okay, we're going to do a simple multiplication. Okay, we first identify how many sig figs we have. You can see that 3.546 has 4 sig figs and 1.4 has 2 sig figs. Okay, also when you do multiplication, don't forget about your units. You're going to multiply meters times meters. So meters times meters is a little bit of algebra here, gives you meter square, right? Bananas times bananas gives you banana square. Sure. All right, so once we do the math, we end up with 4.9644, okay? Since we have 2 sig figs as our least accurate measurement, we got to find the 2 sig fig position, which is the 9, okay? And now we're going to truncate everything to the right of the 9. Use the rounding rule. 6 is greater than 5. That means the 9 goes up to 10. Carry the 1. So our answer is 5.0 meters squared. Don't forget the units because you multiply m times n, which is meters squared. Okay. So multiplying and dividing, focus on sig figs. Adding, subtracting, focus on decimal places. Don't mix the two up. Right. Now, scientific notation, and this is where the calculator that you have really needs you to have the function of scientific notation. Why is that? Scientific notation is nothing more than a means to write humongous numbers like this one here, either very, very large numbers or very, very small numbers. Okay, that's what scientific notation does. And so we can plug that into calculator. Most calculators, handheld calculators, will have a hard time inputting that value. You will have to put it into scientific notation so you can do the mathematics. Once you put the number in scientific notation, the mathematics is the same. Whether you're multiplying 2 small numbers or 2 humongous numbers, the mathematics is the same. It's just a matter of presenting that data in a format that you can deal with humongous numbers. Let's take this number here. This is 93 million, okay? 93 million. What we simply do is we take, this is where the decimal point will be right here, correct? Everybody agree on that? We're going to go from right to left. Notice that we have a number much greater than 1. So the decimal point goes from right to left. And we're going to count the decimal places until such time we find the first integer all by itself, okay? Count the decimal places. So if I start where I marked it here and go across to right in front of the 9, that is 7 decimal places, okay? Now, second thing to notice when you see a big number, first figure out how many sig figs that big number has. So when you convert to scientific notation, your answer should have the same number of significant figures. This 93 million only has 2 sig figs, so we're going to make sure that our answer has 2 sig figs. Okay, so we move the decimal point from right to left until in front of the very first integer. It's all by itself, which is the 9, and so we put 9.3, and then we got times 10 to the 7th power. 7th power tells us how many decimal places we have here. This is just another way to write a number that says 9.3 times 10, 10, and what we got here? 2, 3, 4, 5, 6, 7. This is just another way to write this out. This is supposed to be a point there, not a comma. Okay. And so instead of writing all those tens, we got 7 tens. So it's 1, 2, 3, 4, 5, 6, 7. So each 10 has a superscript of 1. When we multiply these, we add up to the 1. So we got 10 to the 7th power. Okay. So it's 9.3 times 10 to the 7th. The format, the correct format is like it is written here. So it wouldn't be, hold on 1 second. It would not be 93 point something, it would be 9.3. Okay, 9.3. All right, so correct format. Let me clear this up a little bit. All right, so now that's for very large numbers. For very small numbers, we're going from the decimal points right here, as you can see it, 0.000, so on, etc. We're going from left to right, okay? The difference here, for numbers greater than 1, the exponent is a positive number. This is a positive 7. For numbers less than 1, we're going from left to right. It's a number much less than 1. The exponent is a negative number, okay? So it is a negative number. And so it's count the decimal places until we go to the first integer and go immediately behind it. So we count how many sig figs we have here. We only have 2 sig figs. And so we're going to have 1.7 and then times 10 to the negative 10 meters, because we got 10 decimal places. Okay. All right. So here's just the means to write very large numbers or very small numbers, so you can do the calculations. Okay. And these examples here, they ask you to convert the following to scientific notation. Step number 1, count the number of sig figs, because your answer should have the same number of sig figs. So if we take a look at 548.005, we have how many sig figs? 6 of them. Okay. So find the decimal point. The decimal point, this number is a number much greater than 1. So we're going from right to left. And we're going to move it to the left until we find the first integer, which in this case is the 5, and we're going to stop it there. Okay, count the number of positions it took. So here we have 5.48005 times 10 to the 2nd power. Okay. Example number 2 has 3 sig figs. So when we write in scientific notation, we have to make sure we have 3 sig figs. So 6.81 times 10 to the 7th. Okay. Number 3, it's a number less than 1, so automatically tells us our exponent, our superscript is going to be negative. Okay. But how many sig figs do we have? We have 3 sig figs. Remember, those zeros in front of the right after the 4 are significant. So it's 4.00 times 10 to the negative 4. Okay. And then 2000. 2000 only has 1 sig fig. So our answer is 2 times 10 to the 3rd grams. Okay. So when you have a number that you're not sure how to put it in sig figs, how many, there's no question about it. If you type it into scientific notation always has the correct number of sig figs. And the same rules apply. If you take a look at these zeros here, okay, and you ask, are those significant? Well, yeah, they got a decimal point and there's an integer in front of them. So yes, those zeros are significant. So we got 3 sig figs in example number 3. Okay. All right. Now, how to put it into your calculator? Well, there are, most calculators have what are called the double E button, okay? If you look at this example here, the double E button is right here, okay? You might have a different button. You might have an EXP button. Okay. Also, in this example here, the function is primary function, but your scientific notation may be a secondary function. So take a look carefully. Okay. The newer calculators have something that a button that says x10 to some power x. Okay. So if you're not sure, take a screenshot, take a shot. Well, I'm gonna figure out how to. Yeah, take a picture of your calculator, send it to me, and I will be glad to look at it. Sonia, you say you have a question. Go ahead and unmute yourself and ask. Sonia, you had a question?
Oh, sorry. Yeah. I guess I'm just still a little confused. I understand when you have like for the conversions of the scientific notation. I know like I get when like you left and right whether or not, but my thing is, so I'm confused when it says to go 7 up. So for instance, like if I had that first number you were showing, if I don't have 7 numbers to move from the placement, because if there's not a decimal, the decimal or is in the back. So I'm just confused on that. I'm not really understanding.
On your
like, I know which way to move. No, like when you're, well, my calculator too, but I'm just kind of confused when we're getting like the number to the first whole number. So it'd be like 5. It was that example you were showing. Sorry.
That example?
Yeah, the example you were showing.
How about that
I don't know what I did. Let me see. I did something to my computer. Yeah, that one.
The big one?
Yeah, so I understand I'm supposed to go left because it's a big number, but so it's saying 7 decimal places, right? So if I count from the back and go 1, 2, 3, 4, 5, 6, 7, 9 okay, like right there. So it's 9.3. Then you do times 7 or 10, 7.
Yes.
Like to the 7th power, but why 10? Like where do we get the 10 from? That's what I'm confused of.
Oh, okay. Well, I think I had an example. If I were to write this out, okay, 9.3 times 10. I'll get it straight here. One, 2, 3, 4, 5, 6, and 7. If you were to multiply 9.3 times 10 times 10 times 10 times 10 times 10 times 10 times 10, you will have 93 million. Okay? So these zeros, these decimal places represent 10 to the 1 power. Okay? The decimal places that you move either left or right are designated 10 to the 1 power if you go from right to left, or 10 to the -1 if you go from left to right.
Okay, so would the power change is it always going to be to the power 7, or would the power change depending on the amount of spaces you move?
Yes, it would. The 7, if this number had one more 0 to it, then it would be 10 to the 8th. If you had, okay, well, let's try this one. Okay, maybe someone can, how would I write 1, 1,000?
So would it be
Who can do
1 to the 10 to the power of 3rd? I don't know.
You got it. Exactly. 1 times 10. Now I don't have a superscript, so it'll be power to the 3rd. That little arrow represents. Okay.
Okay. If all else fails, you can multiply and check your answer. You should get your original number then.
Yes,
okay.
Exactly.
Okay.
And if I were to multiply 10, 1 times 10 times 10 times 10, guess what? I got 1,000.
Okay. Thank you.
Okay. Does that make sense for everyone? So the decimal point is, every decimal point is 10 to the power of 1. Okay? And so if I multiply 10 to the power of 1 times 10 to the power of 1, it's 10 to the second power, or 10 to the third power, or fourth, however number of decimal places. Does that make sense for everyone? Yeah. Okay. All right. So let me clear this up. So again, scientific notation is nothing more than a means to write big numbers in a format that your calculator can understand. Now, Lubia, you want me to show an example? I will show an example here pretty soon, okay, of how to use your calculator. All right, so when your number is greater than 1, I think to remember, when the number is greater than 1, the exponent is always going to be positive. When the number is less than 1, your exponent is going to be negative, okay? All right, so we went through this example. So here, 2000, we have the decimal point where the decimal point would be wrapped to be the last 0. So we're going to go from right to left. So we count the positions until we get the first, that decimal point is in the first integer. So we go 1, 2, 3. Okay. My mouse is acting up here, not very smooth. And so we end up with 2 times 10 to the third, because we have 3 10 to the 1 units. So 2 times 10 times 10 times 10 is 2000. Okay. And then we were jumping into the calculator. Your calculator can either have a double E button, or it might have a EXP button. Let me do a new share right now. Where's my calculator? Okay. Let's do the Windows calculator. Okay. The Windows calculator, you can see here I got an EXP button. Let me clear this. And so let's say I want to type in 1.5 times 10. Oh, the other button you want to look for, if you look at here, I'm pointing to the button that says +/-. That's the button that makes your number either positive or negative. So if I were to type 4 and I want to make it negative, I push that button, it makes it -4. Click it again. You know, it might be on your calculator a bracket with a negative. That's a toggle back and forth. But you need to find that, and you need to find your EXP button or double E button, or a button that looks like X times 10 to the X. Okay, so I want to input 4 times 10 to the 6th power. So I type in 4, okay? Then I hit the X button. Now notice here what happens, the calculator, the Windows calculator puts an E in front of it. That is telling you that's the exponent. So I just need to type in 4. So that number up here, 4E plus 4, is another way of saying 4 times 10 to the 4th. If it's a negative, I toggle the negative. It's a -4, so that represents 4 times 10 to the -4. Okay. Now, you think your calculator's old? Well, I tell you what, take a picture of your calculator, try to scan in real close to the button so I'll take a look at it. But every scientific calculator, most calculators now have this function. Sometimes they're hidden in the back to the second function. Sometimes they're not up front. Okay. All right. So the point to remember here with your calculator is that the format of the calculator is not the format of scientific notation. So I wouldn't write 4E -4. That would be incorrect. You would write 4 times 10 to the -4. That is the correct scientific notation format. Now at this point, if I want to do the math, then you do the math like you normally would, nothing different. So now I'm going to take 4 times 10 to the -4. I'm going to divide 1.5 times 10 to the 45th power. And I get this answer here, okay, which is 2.66666 times 10 to the negative 49. Obviously, I wouldn't present that. I would have to figure out how many sig figs I had. I think I had 2 sig figs. The least, the number had to, with the least sig figs was 2. So I have to truncate that to 2.7 times 10 to the negative 4. Okay. All right. Let's go back to the calculator. So if, check your calculator. If you have problems with it, shoot me a picture of it. We'll take a look at it and we'll see how it works. Alternatively, you could even, you should have the function to share. And there's not that many of us here. There's 10 of us, but 2 of them are me because I'm using my cell phone so I can see what you see. Because I normally don't see what you see. I want to make sure I'm presenting the material okay. But you're welcome to share a picture of your calculator and we can try to figure it out. But all right, we can do that after class. I have time afterwards today, so there's no time. So you need a calculator. Okay, so of course, forget the rules about you need calculators. This is a rule if we were doing something else. So do not hesitate to use your calculator as needed. You can try working on that practice one. You type in 2.84, then you hit your button times 10 to the second power. In fact, let me see if I could, divide it by 7.24 times 10 to the 12th power. You should get 3.92 times 10 to the 10th power. Let me see if I can bring in my calculator there and we can do that one. Okay, so I would clear it. I got that 2.84, okay, exponent to the 23rd, okay, and then we're going to divide by 7.24 exponent to the 12th power, okay. Then we hit the equal like you normally would. And your calculator may give you this big, gigantic number, okay? Convert that to scientific notation. In the case of, you may have a button called SCI, or you may have this button that I'm pointing to, FE, where it goes from fixed to engineering. If I click it, it puts it in scientific notation, okay? That number, the numbers we just multiplied had 3 sig figs, so I got 3.92. I got to truncate it after the first 2 times 10 to the 10th power would be my answer, which is what we had in this example. Okay, so feel free to ask me about the button. This format here sometimes depends on the calculator. It might give your answer in this format. That is not scientific notation format. Depends on your calculator, what the calculator is telling you. This is 1.23456 times 10 to the 8th power, okay? So, let me clear everything. All right. Now, I think the last topic for this chapter is part over whole. You probably already have a grasp of this. Yeah, think of it in terms of an exam. Okay, you got 100 points in the exam. You scored 80 points. What's your average? 80%, right? the part is what you scored. The whole is the total number of points for that exam. So 80 over 100 times 100 is 80%. Okay, there's no different here. Here in this example, it says you got a gold ring. It has a mass of 239.45 grams. And it was analyzed, and it contains 198.3 grams of pure gold. What percent of this ring is gold? So identify the part. The part is 198.38, and the whole is the total weight of the ring, which is 239.45. Plug it in to your calculator, times 100, and we get this big, humongous number. Obviously, we can only be as accurate as the least accurate number here with the least sig figs. In this case, both the numerator and denominator have the same number of sig figs, so we have to truncate after the, we have to truncate right here at this 8 right there, okay? Because that is 5 significant figures position. We got 5 over here and 5 sig figs over here. So our answer should have no more than 5 sig figs. Now, I understand you might be tempted to want to type that whole number in there, but this is science. We have to be as accurate as we can. That does not mean that if you give that whole answer, that does not mean you're being more accurate, because your measurements are only accurate to 5 sig figs, okay? You did not measure. If you were to measure with an instrument that had all those significant figures, then obviously that's how you present it. But you did not. You're limited by 5 sig figs. So in this case, 82.848% of this ring is gold, pure gold. Now the worksheets, don't forget to do the worksheets. Okay, there's a lot of stuff there that we need to do, to help you out. The more you do, the better off you are with respect to these problems. And I'm going to share with you. This is I don't know why it's clapping. I'm going to share with you a file which I did email to you already, but I'm going to share with you something I put together, because sometimes with respect to within the units, metric units, those are something you're going to have to learn, okay? How to go from one unit to the other within the unit, within the English and the metric unit. And so what I put together here is a little table. I emailed this for you, okay? We got a kilogram, which is equal to 1,000 grams. And then we have 1 gram is equal to 110 decigrams. Now, the confusing part is, well, how many decigrams? But I think everybody knows how many decades in a year. Does everybody know how many decades in a year? Isn't that 10? Does everybody know how many centuries, how many years in a century? Isn't that 100? Okay. That's what I'm highlighting here. So in 1 gram, there are 10 decigrams, or 100 centigrams, or 1,000 milligrams. This unit here that I highlighted, the last one where you have 1,000,000, that looks like a U, that's a microgram. Okay, that's a microgram. So there are 1,000,000 micrograms in 1 gram. Now, the same prefixes, this is for mass, the same prefixes apply for volume. We got 1 kiloliter, there's 1,000 liters in a kiloliter. We have 1 kilogram, there's 1,000 grams in 1 kilogram. In 1 liter, there are 10 deciliters, or 100 centiliters, or 1,000 milliliters, or 1,000,000 microliters. When it comes to length, same scenario. 1 kilometer there are 1,000 meters. And in 1 meter, there are 10 decimeters, 100 centimeters, 1,000 millimeters, and 1,000,000 micrometers, okay? every one of these things, every one of these are conversion factors in their ratios. That means that we can set them up one or two ways. Like I've written here, I got kilograms in the numerator and grams in the denominator, or I can invert it, okay? And so I have 1, 2, 3, 4, 5 for the mass, five conversion factors, which means I can write those 5. I have a total of 10 ways to write each one. What? 2 ways for each one gives me a total of 10 conversion factors for the mass, which is true for the volume, which is true for the length. Okay. Now, how would I use that? Let's take this example here. Question is, how many micrograms are in 0.125 kilograms? Okay. Well, first thing we do, we write down what we know. 0.25, that's what we're given, kilograms. Going back to this table, I know that in 1,000, I can't go directly to micrograms, but I can go to grams because I know that in 1 kilogram, there's 1,000 grams. And I write it with grams on top and kilograms in the denominator. Why do I want to do that? Because I'm trying to get rid of kilograms. And I got a line over it. You notice the units cancel. So I set that up. So if I were to stop the calculation at this point, the units I would have is in grams. But they're asking me for micrograms. So I need to put in one more factor. Well, what other factor do I know? I know that in 1 gram, there's 1,000,000 micrograms. So I set it up with micrograms in the numerator because those are the units I'm looking for. Okay. And my grams cancel. So you can see by following the units and canceling things out, I got the problem set up properly. Okay. And now I simply now plug it into my calculator and do the math. And so I end up with 125 million. Now, Sonia, if I were to write that number in scientific notation, what would that number, how would it look like? What would you say?
I know the power would be 6, but if I moved, it would be. So would it be 1.25 times 10 to the 6th?
Okay, starting from the last 0, how many decimal places do you get in front of the 1?
6? Oh, sorry, no.
Many?
9? 9?
9?
Am I counting? Yeah.
No. To the front of the 1.
Oh. 3, right? I'm confused.
Okay. How about from 1 to 5? 0, 0, 0, 0, 0, 0. And so I go, I don't know if you can see my mouse here.
Yep.
So I go, that's 1, right?
Yeah. 2.
2, 3, 4, 5, 6, 7, 8.
Oh, and okay, 8. Okay.
1.25
times
10
to 6, right?
to the 8th. Oh, wait. I got to put my super script. 8. Does everybody see that?
Wait, why is it to the 8th?
To the 8th, because that, starting from there, would you agree that's my decimal point, right?
Mm-hmm.
Okay, so I go over 1, that's 1, 2, 3, 4, 5, 6, 7, 8.
Oh, the amount, you're moving the decimal, okay.
Yeah, I got to move to the first integer all by itself. And that's
Okay.
8 positions. Okay. Okay, the decimal point just counting the zeros here because we know there's 3 decimal points from here to here. Everybody see that? Is that 3 decimal points?
Yes.
And there's 3 more right here.
Yes.
And there's only 2 right here.
Yes.
So the total is 8. Do you see that? So large numbers, you start at the right to left. That's correct, Paola. That's
no matter how big the number is, you're always going to go to the first whole number.
To the first whole number right in front, to the first whole number all by itself.
Okay.
Okay. And so if this, maybe because the commas are, let me get rid of the commas. Because if we were to add 3 more zeros, okay, how many decimal places would that be?
So 11.
Right? 11, right? So we would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that number would be 11, 10 to 11. Yes, Paola, yes. So for large numbers, you're going from wherever the decimal point is, you're going from right to left. Okay. And if you were going to reverse that and go 0.001, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 5, I got to move from left. First of all, it's a number less than 1. So I'm starting right there, right? So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that would be 1.25 times 10 to the negative 11. Negative 11, because it's a number less than 1. Exactly. Regina, you got it correct. Gotcha. All right. All right. So now in the shapes table, we give you these conversion factors. Now these are factors that you are within the metric unit. Okay. So you may need them when you're going, I got kilograms, I got to go to micrograms. Keep it in mind the prefix, the D for decades, 10 years in a decade. Does that make sense? 100 years in a century. How many years in the millennium? Anybody know? 1,000. And there's 1,000,000 microns. Okay. And you can use those prefixes for mass, volume, and length. That's the beauty about the metric system. A little bit different with the English units. Okay. So, but if sometimes you're given these factors in the shapes table. So these are ratios. I can write them any way. See how I wrote them with inch on top or inch in denominator. How I use them depends on the question. Okay. And this is true for any ratio, whether it's you're working $50 an hour, I can set that up as a ratio, 50 over 1 hour or 1 hour over 50. And depending on the question and keeping track of my units, I set it up and making sure units cancel out. Okay. Or if I'm driving speed, 100 miles per hour, I can say 100 miles per 1 hour or 1 hour per 100 miles. Right? Doesn't this make sense? If you're traveling 100 miles per hour, how many miles would you get in 10 hours? Well, I would use the factor on the left, 100 miles per hour, because I multiply that factor by 10 hours. Do not my hours cancel out? And now it's 100 times 10, which is 1,000 miles. Okay. Now, just a quick review as far as units are concerned. 10 to the square the square of A, I should say, divided by A. Well, when you see anything with a superscript, A to the square, A to the third, it's just a short way of writing A times A. I could have A to 100 power. That would mean 100 A's, A times A times A times A times A. But I can write it out like I did here, and then I know I can see my common factors cancel, my A's cancel, so my answer would be A, okay? Or if I multiply A times A, it's A squared, or A times A times A cubed, okay? Apple times apple times apple, apple cubed. But what is apple plus apple? 2 apples.
Two apples.
Exactly. If I multiply, it's to whatever power it is. If I add, it's, you know, I can only add like terms. Okay, so, oh, and then I got this little image for you with respect to the English units, because cups and pipes can be a little bit confusing. But if you look at the big G here, that's the gallon, okay? Now, how many Q's do you see within the big G? 4. So there's 4 quarts to 1 gallon. Now take a look at just 1 Q. How many P's do you see within 1 Q? There's 2 P's. P's for pints. And within the pint, there are 2 C's for 2 cups. So 2 cups in 1 pint, 2 pints in 1 quart, and 4 quarts in a gallon. Again, 6 conversion factors. Excuse me, 3 conversion factors here. Okay, that you can set up in any ratio that you want, because you may need to be asked to go from milliliters to cups. Well, if I need to go from milliliters to cups, I have these conversion factors that give me milliliters to quarts, and then from quarts I can go to pints, and from pints to cups. Okay, so that little picture may help you out. All right, so this is the thing I sent to you, this file. I was planning to jump into number 3, but anyway, it's pretty short chapter. We'll knock it out tomorrow. Shouldn't have a problem. And those of you who are here, I can continue with this chapter on Friday during the office hour. Okay. If those hours don't work for you, let me know. I'm pretty flexible with respect to time. We can do a Zoom or to help you out whatever way you need. So, any questions? And that activity, I will fix that activity, so it should be more chapter 3 than chapter 2. Maybe I'll label it chapter 2 and 3, and I'll move the date a little bit. And if you've done it, send me an email through Canvas to remind me to give you another attempt. Okay. Okay, great. Keep up with the activities. Keep up with the homework, and hopefully don't wait to the last minute. Okay. All right. So we'll call it a day today, and we'll continue with chapter 3 tomorrow. All right. You guys take care. Stay safe out there.